I think that's all the updates I have for you all. If you don't have any questions, we'll get started on today's stuff, which actually we're going to spend at least a couple sessions on today's next section because there's a kind of a lot going on in it. There's a few different string methods that we're going to be covering, but I think it takes a little bit of going into before you kind of understand what's going on, especially with this first one that we're going to look at. So let me open up the assignment on here because you'll see how involved it is by all the attachments that I've added. So don't be afraid. I'll kind of explain what's going on here. So let's just go over the resources that are on here first. First, I just have a link to the assignment on CodeHS, and so that's just the section 2.8 string methods that I already have open here. As you can see, there's 5 exercises, there's 3 examples, and we'll get through at least this first one today, so you don't necessarily need to start working on the homework today since we won't get through all the examples or anything. What I would recommend, though, is for homework today to at least watch the video and do this little quiz thing. That way you're kind of prepared. We'll probably just cover this today, and then next class we'll go over these 2 examples. The other resources I have here is the actual documentation for the string class, which we're going to go over a few things. We're going to go at least over one thing today in here, and then maybe a couple other things next session. And then I also have something that you might have seen if you took like AP Computer Science Principles, which is an Ascii reference sheet, which is so Ascii is a convention called American Standard Code for Information Interchange, and it's a standard of how different characters, like on your keyboard, are represented on the computer. So if you haven't heard of bits and bytes, bit stands for binary. Oh, hang on, you won't see that. I forgot that. I need to annotate with this. So bit, if you don't know, stands for, let's change that color. Wow, it's been a while since I used this, so where is the color? Text. Nope. Format, there we go. Okay, so bit stands for binary digit. Has anyone heard of binary before in terms of numbers? Or even just like outside of numbers? Have you heard of binary? And if so, what does it mean? All right, so not seeing anyone really saying anything. So binary, yeah, it is like an on-off thing. So binary, just like by itself, means that it's something that has only 2 types of things, right? That comes from bi, which means 2. In computer science, those 2 things are represented by 0 and 1, with 0 being off and 1 being on. The off and on comes from the notion that all computers use, well, back in the day, they used physical switches. Back in the day when computers were very, very, very huge and were basically filled the whole room, they used these physical switches that people would actually manually turn on and off to allow electricity to actually flow between them. And so off meant that there was no actual charge going through that switch, and on meant that there was an electric charge going through that switch. And by creating these, different patterns of on and off, you're able to represent numbers, like the numbers that we see basically, or the numbers that we use. So the numbers that we use are the things like you see on the left here, like 32, 33. These are all base 10. They're also called decimal numbers. But notice that you could represent the same number in a series of bits and on and off. Okay, and so right now you don't really know, you don't need to know how bits actually convert to this. I can go through that if that's interesting to you, but you actually don't need to know it for this class for some reason. You need to know it in computer science principles, but not for computer science A. So just trust for now that this sequence of bits of offs and ons or zeros and ones actually translates into this number 32 here, and so on as you see going on through this chart. So why am I showing you this? It's because the first method that we're going to cover in this class is a string method that actually compares the bits of each character to find out what word comes first in the dictionary and what comes after it. So let's kind of go to that section on code.org. So I'll go ahead and get rid of this. And go to the mouse. Okay, so I'm going to go over to code.org, and what I'm looking at is the first example, which is called bigger strings. So in this example, basically they want us to play around with it, run and change the code, and learn how it works. So let's do that together. All right, so notice that we've got these two strings here. So let's kind of draw this out. So we've got one string here, and then we got another string here. So these are the reference variables, and here's where the actual value will be. Remember, because string is an object type, meaning that it has a reference, a place in memory that points to another place of memory where the actual value lives. Oh, I just realized I was using the wrong annotation. I'm sorry. Yeah, sorry. Yeah, it's the first day back. My brain's not gonna work well, and you're probably in the same boat. So we're gonna take it nice and slow today. Let's see. So the first string is called first. It's of string type. Thank you. And the next string is called last, and that's also string. All right, so these are each gonna point to a string. Let's draw an arrow that points over there. And so our first string is gonna be apple. Apple. And then last, the name of the variable last is going to point to zebra. Okay, so the objective of this program is to find out which word comes first in the dictionary and which one comes last in the dictionary. Like not physically first, but basically which word would come before the other in the dictionary. So just looking at this conceptually, we know that apple comes before zebra in the dictionary. So we would expect to see that the computer will tell us apple comes before zebra, right? Because we're looking at the alphabetical order. Okay, so how the heck do we make the computer do this? Well, it turns out that there is a string method called compareTo. And so you can kind of see the first instance of its usage right here. So compareTo. And how do you use it? Well, you have to have two strings. You have to use this string that calls it. So you can tell that this is the string that calls it because it has the dot and then the method call. And then you have to supply it with a second string to compare it to. So what is this actually asking? this is asking, this whole phrase is asking, does this string come before this string? So you can think of that as this question. So let's actually pause there and let's look at the documentation for this, because why the heck does it say first dot compared to last is less than 0? Why would we want to see if this is less than 0? And that's a very good question. So let's take a look at, I'm going to leave these annotations up here. So let's take a look at what this method actually does, this compareTo method. So that's why I have linked the documentation here. And remember how I told you, just take a deep breath, don't be overwhelmed, because documentation is kind of a lot. But we're gonna start to take a look at documentation a little bit by little bit, just to get you used to it. It does take some getting used to, because look at this is so much information, and you don't need to know most of this stuff. But we will practice looking at documentation for some of the methods that we'll be learning. So what I want to take a look at is, this is just the string class. And they give you different examples of how to declare strings and all that stuff. It'll give you different components like field summary, which we don't really need to know about. The constructor is nice to know, because the string is an object type. You can construct a new string with this constructor. But again, we don't really care about all these different ones down here. I'm going to skip down to where it says methods, because right now we're learning about string methods. And we're not going to learn all of these, because look at how many there are. That's just a ridiculous amount to cover in a single class. We don't really need all of these. What we want to look for is the method that we just saw in the example, which is compareTo. So thankfully, these are all sorted in alphabetical order, and so I can find it here. So this isn't a ton of information in this row, but you can always click on the name of the method and it'll talk a little bit more in depth of what this method actually does. So if I click on compareTo, I get a more in-depth explanation. Let me actually just erase these two things for now. I'll leave our diagram here. Okay, so again, like I said before, the way that you use this method is that you are going to call the compareTo method and pass in another string to compare it to. It turns out that here's the return type, right? You get an integer back. But right now we don't know what that integer means yet, so that's kind of why I wanted to look at this. Why do we get an integer back, and what do we do with that information? Okay, so this method compareTo compares two strings lexicographically. The heck does that mean, right? Lexicographically means comparing its actual letters. So it compares it, you could say, alphabetically. Okay, so it kind of looks at each character in the string and compares each character that's in the same position of the string. So if I had apple, well, I guess I have them here, apple and zebra, it would start off looking at the first letter in the string and compare those two. And what is going to happen when it compares those two letters? Well, let's read on. The comparison is based on the Unicode value of each character in the strings. So the Unicode value is basically the same thing as what I showed you in the Ascii chart. So let's take a look at that. Did I close it? I did close it, of course. So let's go, oh no, it's right here. Okay, so when we're comparing the two letters, so remember we have apple and zebra, and we are first going to compare the first two letters, what it does is it uses its numeric value. So let's find A. A is right here. Let me circle that for now. So we've got A, and then we got Z down here. Now we see that there are these, this binary number that represents both of them. Remember, in this class, you're not really expected to know binary and how to convert it to numbers, which is why, I gave you this chart. So we've got 97 here, and we've got 122 here. So basically what our method call does, so if I were to call first dot compare to last, that means that we're comparing apple and zebra and we're going letter by letter. So first we're comparing A and Z. What this is actually doing is it is taking the numeric value of A, which is 97. So let's put that here. Let me change the color so you can see it. Let's do purple. All right, so A is 97. And then what it's going to do is it's comparing it to last. So we're looking at this letter here, Z. So we're going to subtract 122. So you're finding the difference in the numeric value of those first letters. And if this number is something other than 0, it's actually going to stop comparing because it's already found a difference. Okay, so if this number is not 0, if it's greater than or less than 0, it's going to stop what it's doing. So already we see that this number is not going to be 0, so we're actually going to stop execution. And we actually don't even need to all the way calculate what this number is. All we care is that this value is going to be negative. So if this value is negative, it means that apple comes before zebra in the dictionary. And you're like, okay, yeah, I know that, teacher. But the computer doesn't know that. The computer needs to actually physically compare these numeric values. So this is how the compareTo method works, right? So one more time, let's kind of go through it. So what it does is it takes the string that's calling the method. So in this case, that's the string that is referred to by first, so apple. And it compares it to the other string that you pass in as the parameter. In this case, it's last, which is the string zebra. It goes through and compares each letter at the same position in both strings. If at any point the comparison that comes out from subtracting the two numeric values is something other than 0, it's going to stop. It's going to stop comparing letters. If your number is negative, the first word is going to be considered first in the alphabet. If the number is positive, that means the other string comes first in the alphabet. Okay, so now let's actually take a look and spend the last few minutes of class taking a look at the example in code.org, or not code.org, CodeHS, to see how this actually works. So I'm going to go back to here, clean this up a little bit. All right, so right here on line, let's see, 11, this line right here, line 11, we see a Boolean value being declared. Okay, and this Boolean value is going to be true if this method call returns a number that is less than 0. So basically, if this is negative, okay? So if this is negative, we're gonna get true back here. That's gonna mean that apple comes before zebra in the dictionary, okay? So it will print out that message that apple comes before zebra in the dictionary. All right, so let's see what happens. We already know, because we did the calculation, that the number is going to be negative, which means that it's going to be less than 0. So let's see if we get that result. Let's see if our prediction is right. Let's run the code. All right, so we can see that it asks, does apple come before zebra? We got back a negative number, like we said. We didn't actually calculate the number because it doesn't matter, but it's negative 25. That means that it's true, right? This evaluation is true, that the number is less than 0. And then it says, does zebra come before apple? That's the other question that they want to answer. So now they're comparing it the other way around. They are actually taking zebra first. So 122 minus 97. And then you'll get a positive number, so you'll get false. That zebra does not come first before apple. Okay. We will continue this. I know it's a lot to kind of take in. This method I found really, really confusing when I was first starting Java programming. So we will kind of like go back over this. But it's 10:31, so I don't want to keep you much after.